Okay, welcome to the tutorial on sets. As usual, we'll go through a brief introduction about sets and why they're useful, and I'll show you the different functions that you can use with them, and then I'll finish up with an example problem. Okay, to introduce sets, let's look at a problem that we sometimes encounter with lists. We sometimes encounter this situation where we want to remove all the duplicate elements from a list. This is quite a slow task because the only tools we have for this are for loops and while loops and stuff like that. So what we have to do is start at the first item, then go through the rest of them one by one and see if there's anything that matches this one. Then we have to go start at the next one and compare it to all the other items, and when we find the duplicate, remove that from the list, and so on for every other one. For something that we have to do so often, this is quite a long-winded way to do it, and it's also a very inefficient way to do it. So this is one of the problems that can be solved by sets. Okay, sets are like lists, but any duplicate items are ignored. So if you add an item to a set that already contains that item, it won't have any effect. And the items aren't in any particular order either, meaning that you can't say something like my underscore set and then some index, because they're not in order. And because sets work this way, they can do some things faster than lists, like checking if an item is in the set. Okay, sets are denoted by curly brackets, but because dictionaries are also denoted by curly brackets, when you're creating an empty set, you need to use the built-in set function. So with lists, you just used to put in empty square brackets to create an empty set, but if you try to put in empty curly brackets here, it won't treat it as a set, it'll treat it as a dictionary. We can also convert a string into a set, and this is similar to what a list does when you use the list method to convert a string into a list. And what this does is, if we take our string here and convert it into a set, then the set will be each individual character, but it'll remove the duplicates from the set. So that extra A and that extra B will be gone. It's the same idea with lists. If you convert a list into a set, it'll remove any duplicate elements in the list when it's converting it into a set. And once again, the set isn't in any particular order. We can add elements to a set using the add method. This is pretty much equivalent to the append method for lists. So if we make an empty set called my underscore set here, and if we want to add an element to this set, we say my underscore set dot add, and then in the brackets here we give it the element that we want to add, and this can be a variable or an integer or a string or a float or any kind of data. And when we want to remove elements, because the set isn't in any particular order, we don't generally do it the same way we do with lists, where we're removing by index. So we generally remove by value by saying name set dot remove, and then in the brackets here we're telling it to remove this A element, and it'll get rid of that from the set, as you can see down here. Sets in Python represent the concept of a mathematical set. So if you remember your Venn diagrams, there's a few useful things that we can do with sets. Let's say we have two sets here, set 1 and set 2, and the first set contains the numbers 1 and 3, and the second set contains the numbers 2, 3, and 4. One of the things we can do is use the difference method to find what elements are in one set that aren't in another set. So the way you use this is give it the name of the set, so set2 dot difference, and in the brackets tell it which set that you want to subtract from it. So in this case we're subtracting all the values in set 1 from set 2, and that just takes away the 3 and leaves us with 2 and 4. You can also use the intersection method, which finds the elements that the two sets have in common. So if you say set2 dot intersection of set 1, that will just give you this portion in the middle here. And finally, you can use the union method in the same manner to join together all the values of the two sets, and in that case you get all the values that are in set 1 and all the values that are in set 2, as you can see there. Okay, there's a lot more functions for sets, but we don't really need them at this time. So if you want more details, the notes on this topic has a pretty good rundown of the functions that belong to sets. The only thing to add is that things like the len function and the for loop work on sets the same way as they do on lists. So we just run through some quick examples before we finish this up. The first part of this example is to just ask the user to enter a sentence and then print out all of the letters that are not used in that sentence. So as usual, just use the input statement to ask them to enter a sentence. And now we want to find out all the letters that are not used in that sentence. We don't have an easy way of finding out the letters that are not used, but we can start by finding all the characters that are used, and we can do that by converting this s thing into a set. So if I store that in a variable called unique, that should represent all the unique characters in the string. And so if I print that out and just run the program, okay, so if I just paste in some text, you'll see we're given all of the unique characters from what I've typed in here. But that also includes uppercase. So just one little thing I'm going to change here is I'm going to convert the string to all lowercase before we do that. If I paste that in again, see that capital T is now gone and it's replaced by a lowercase t. Okay, so how do we find all of the alphabetical characters that are not in the string? If we go back to what we were doing here with set functions, you'll see that one way we could do it is to subtract two sets. So we have the set of all the characters, all the alphabetical characters from A to Z, and if we subtract the set of all the characters that they've typed in, then we'll be left with the characters that they didn't type in. Okay, so back to the program here. I don't want to print this out anymore, so I'll just get rid of it. And what we're going to do is create another set that just contains all the characters from A to Z. And we'll store that in a variable called letters set. Okay, so if we subtract the two sets using the difference function, so we're subtracting whatever's in unique from letters set. And we'll store that in another variable. So we'll call that one not typed. And let's just print it out there and see how we're getting on. That gives us the set of all the characters that are not included in this string. Let's just look at an alternate way to do that. I'm just going to keep these two lines here and get rid of the rest for now. Well, another way we could have done this, and there's plenty of ways to do this, we could have gone through the sentence character by character, and if it was a letter, we could remove it from this set here. Right, so if you remember from the strings video, if you want to go through a string character by character, you can say for something in S. So we'll just call this for letter in S, and we can go through it character by character now. So we want to check if that character is in this set here. So you can do that the same way you do with lists. If letter is the name of our character in letters set. Okay, so if the current letter we're on is in this set here, then everything that's indented here will run. So if it is in the set, we want to remove it from it. So we can use the remove method for that. We want to remove letter from the letters set. And at the end, I'll just print out letter set and see that we get a similar result. Okay, and you see we get an identical list because we've gone through each one of these letters here. And so if we find a T, we remove it from this set. If we find a P, we remove it from this set. And so on until the end of the string. And we're left with just the letters that weren't in the string. Okay, I'm going to add kind of a part 2 to this, and I'm going to ask how many duplicate letters are in the string. Now the way we could do that is we could find out the number of letters that are in the string and subtract it from the total number of unique letters. Okay, so if we wanted to find the number of unique letters in this S string, we just use set and call that unique. So we're converting S into a set and just storing it in a variable called unique. Now you saw in the previous strings video an example of how to count the number of occurrences of the letter I in a string. So I'm going to do something similar here, but we're going to try and check for all alphabetical characters. So again, just looping through all of the characters in S. But this time we want to check if the character is alphabetic. So if letter dot, and you can see this from your notes if you want to find it out, there's a function called isAlpha here, and that checks if the letter is alphabetic. Okay, and since we want to count alphabetic letters, we'll make a variable here to store how many alphabetic letters are in the string. Okay, so we'll call that letters in S, and we just start it off at 0, and if we find a letter in the string, we just increment it by 1. Okay, so if we go back to here, we're counting the number of alphabetic letters in this string, and we're comparing it, we're going to subtract it from the number of unique letters, and that should give us the amount of duplicates in the string. Right, so we'll call that variable result, and that's going to be the number of letters in the string S minus the length of our unique set. So the number of letters in the string S minus the number of unique characters, and that should give us the amount of duplicates. And finally, we just print that out. Okay, so if you run this one more time, and we get the number of duplicate characters is 14. I'm not going to make you sit through that while I count them up, but that is the correct answer.